Hey everyone, welcome back to yet another problem. Today let us solve the LeetCodes daily challenge, and the problem is implement queue using stacks. Implement a first in first out queue using only two stacks, and the implemented queue should support all the functions like a normal queue, which is push, peek, pop, and empty. Implement the myQueue class where void push if this function is called, this pushes the element x to back of the queue, and pop removes the element from the front of the queue and returns it, and int peek returns an element at the front of the queue, and boolean empty returns true if the queue is empty, false otherwise. So you must use only standard operations of stack, which means push to pop and peek and pop from the top, and size and is empty operations are valid. Depending on your language, the stack may be supported natively. You must simulate a stack using a list or DQ, double-ended queue, as long as you use only a stack standard operations. So what does this problem states is we have to implement the functions for queue, but we are not allowed to use a queue. Instead we have to use a stack. That is the problem, and let us solve. So whenever this my queue is going to be the object that is going to create when the constructor is called. Now I'm calling this push function with the integer 1, so I should use a stack. So let us have one stack 1. Let's say we are having one stack 1, and I'm going to push that 1 into our stack. As you can see, uh, we are allowed to use only two stacks. So that is why I have used s1. S1 is the stack 1. Consider it as stack 1. So stack is nothing but the first in last out functionality. So we can push 1 to our stack, and let's say we are actually performing the next push operation, and we are pushing 2 into our stack. So whenever I call this peek function, as in our queue, when 1 and 2 are pushed, and when we call this top of the queue, then we have to return 1, but we are having a stack, so we will be tend to return 2. So what we can do is actually we can take if there are n elements into our stack 1, let us take n minus 1 elements and put it in our stack 2. Let's say we are having a stack 2. I am popping n minus 1 elements, and I am pushing 1 by 1 into my stack 2. So let's say I have popped 2 and pushed it into my stack 2. Now what we are left out is we are having only one element, that is nothing but the peek element of the peek element when it is implemented in queue. So the way we can just return that peek is nothing but that we can just return that one here. And similarly, we want to pop that element, then we can just remove this element from the stack 1 itself. But what if after performing this operation we want to restore these elements which are in stack 2 to stack 1? So again we will be one by one removing the element from stack 2, and I will be pushing it into my stack 1. That is simple, but let us see an example so that you will be more clear. So we can have push 1, then again what I'll be doing is push 2, then push 3, then pop. So what does that mean is I will be pushing in stack 1, and then 2 is pushed, and then 3 is pushed. And whenever I call this, let us say we are calling the peek before the pop. So if I call the peek element, I have to return 1. So what I'll be doing is I'll be removing from one by one the element from the stack 1, and I'll be pushing it into my stack 2, and that is only n minus 1 elements will be removed, and the last element is nothing but the peek element 1 I will be returning back. But when I call this pop, but after doing the peek operation, again what I will be doing is one by one I will be removing from the stack 2, and I will be pushing it into my stack 1, so that this stack 2 acts as a temporary stack. to store the elements. So whenever I call this pop function, again I will be removing n minus 1 elements from the stack 1, and I will pop the last element within stack 1, and then I will be one by one pushing the elements from stack 2 to stack 1, and like this. Now my stack will be containing 2 and 3. So hope you understand the logic behind this. So we are making the pop operation costly. So our time complexity here is nothing but our time complexity for this push operation is going to be order of 1. The time complexity for our pop operation is going to be order of n, and for peak as well it is going to be order of n. For empty it is going to be order of 1. So these are the time complexities that we will be doing in our problem now. So whenever my queue is my object is created, we can just create an object. We can just create a stack, stack of int s1 and s2. So s1 and s2. Now inside the constructor we can have a while loop. While my stack is not empty, s1 is not empty, I can just pop and I can just clear this, and similarly I can do it for the second stack as well. And now I'm going to push the element that comes in this method to my stack 1, push of x. So whenever I call this pop operation, what I'm going to do is, while my stack is not empty, stack 1 is not empty, and my stack s1 dot size is greater than 1, what I'm going to do is I will be popping that element from stack 1 and I will be pushing that element to my stack 2. So stack 2 dot push of stack 1 dot top, and then stack 1 dot pop. So I'll be doing this. Then I will be having one element in my pop. Always there will be one element in my pop, right? All the calls are valid. So what I'll be doing is I'll be taking the top element, which is nothing but we have to return the element from the first front of the queue and returns it. Okay, the top element is nothing but the s1 dot top, and I'm going to pop that element since this is a pop function. Now what I'll be doing is I will be again removing the element from the stack 2, and I will be pushing it into my stack 1. If my stack 2 is not empty, just stack 1 dot push of my stack 2 dot top and stack 2 dot pop. That's it. And finally return the top element. So this is simple. Similarly, the peak function is also the same, but what is the difference is nothing but it is going to pop. It is not going to pop. It is not going to pop. That is the difference. So it will return the top element, and we can just return if my stack is empty, returns true, and it is not false. Return s1 dot empty. Returns true if the stack is empty. If my s1 is empty, then just, and I can also have this function to be empty as well. I don't want it is enough. And now what we have left, somewhere I saw some -1, right? Not right. Pushes the element, removes the element from the front of the queue, and returns that element, that pop, and returns the element at the front of the queue, peak, and bool empty returns true if the empty queue is empty and false otherwise. Okay, That's it. So here, as you can see that we can try to do some protective code. Here, as you can see that these pop and peek function are both same functionality, that is doing only one line is added, which is this s1 dot pop. So what we can do is we can eliminate this code, and what we can do is we can call one function, one common function, so that we can do it there. So what we can do is we can say take int top is equal to get top from get top. I'm going to call this function get top. I'm just returning this top element. So similar stuff I'm going to do. I'm going to define this in my get top function. So what I'm going to do is I'm just copying and pasting here, and I'm going to give a boolean flag. If my flag is true, I'm going to pop. If my flag is false, I'm not going to pop. Only that is going to be the case here. So hope you are understanding what I'm doing is. So if I want to pop, I will be giving as true here, and if I'm not going to pop, I'm just going to give false here. So it is quite clean, because when I get this pop function, I'm going to do the same functionality, and in peek function as well I'm going to do the same functionality. So we can just take and put it in some other function, and we can call that function. So now let us try to run our code. Sorry. Superb, it gets accepted. Now let us submit the code. It should work, I guess. I have not made any wrong. Great, it gets accepted. Hope you like the solution, and let me know in the comments if there are any suggestions. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.